morning, everyone. Welcome to Nanopayments, the game. I'm Nathan Handler. This is my colleague, Justin Sheek. We both work at Orchid. So VPNs have been growing more and more popular as a means of stopping governments and corporations from monitoring, inspecting, and blocking your internet traffic. While traditional VPNs typically work well enough, they suffer from inherent weaknesses around centralized trust-based models. How do you know that your provider isn't logging or sharing your data due to government coercion or for additional revenue? Lock-in from macro payment limitations or the length of contracts also prevents cheaply and rapidly switching providers when blocked or when they're slow. And finally, paying with credit cards associates key personal identifying information along with all of your internet activity. Some people might try to avoid this lock-in by using one or more free VPNs. Being free to use is not actually an advantage. Free VPN providers, as well as Tor, typically suffer in terms of performance or security. This is where Orchid comes into play. Orchid is a decentralized, open-source bandwidth marketplace built on top of Ethereum. It supports connecting with multiple hops as well as staking. In addition, it utilizes a technology called Probabilistic Nanopayments to solve some of these issues around payments, as well as others that we'll talk about later.
Okay, let's start by examining how traditional fiat payments will stack up against probabilistic payments. So we're going to walk you through a few exercises and sort of demonstrate what the differences are between our payment system and traditional payments, and also if you're familiar with payment channels, we'll show some differences between those as well. All right, so we've got some props. With traditional payment systems, for instance, you might use a credit card to pay $1 for something. However, with our system, with probabilistic nanopayments, instead what you'll send is a lottery ticket with a 1% chance of $100. So in either case, it's $1 that's being transferred, and we'll show you how that adds up to the same way. Let's examine the difference now through a quick exercise. So Nathan and I will just go ahead and walk you through that. Okay, so let's say your goal in this exercise is to stream a 4K movie, and let's just, for the sake of argument, say it's about 20 gigs in size, and that bandwidth is going to, in total, be about $1 worth of bandwidth to stream that movie. So the pink tickets that we're going to show you are going to represent $1 in fiat. So this is going to be just a really basic example. And orange tickets that we're handing over will represent the nanopayments with a 10% chance of being worth $1. And the blue tickets will signify the bandwidth in 10-cent increments. So about a few gigabytes, 2 gigabytes, say, of bandwidth. So first we'll demonstrate traditional payments. So please, okay, you have the. I thought you had the tickets. Here. All right. So he's got some pink tickets, which are going to represent just a traditional fiat, and I'm going to have some bandwidth that I'm trying to sell him. Okay, so I'll say, please, okay, hand over your payment of $1. One pink ticket, great. And then in return, I'll just give him, 10 of these bandwidth tickets. Great, okay. So he got the whole movie in one go, and that's how sort of more a traditional payment system might work. Whereas in a traditional, in a probabilistic setting, instead, what we're going to do is we're going to hand over. He's going to hand over some fiat. You still have the pink tickets? Yeah, okay. So he's going to take 2 of those pink tickets, and he's going to lock them up into the Orchid smart contract. So this is not going to come to me as the recipient. It's going to go into an escrow. And now that it's in the escrow, I can confirm by looking at the Ethereum blockchain that Nathan actually has money to be able to send to me, so that I can honor his probabilistic payments because I know they're backed by real currency. So I'm going to hand him some orange tickets. Now instead, when he hands me an orange ticket, he's only handing me a very small amount of value. He's not handing me the full $1. So I'm only going to give him a little bit of bandwidth in return. So now he's downloaded a little bit of the movie, and I've received a little bit of the payment. And we can repeat this interactively, one at a time, and if only I had 3 hands. So I'll continue giving him bandwidth in response. He'll keep giving me payment. And we'll just pretend that we did this, 8 or 9 more times. Just hand me a few tickets, right? For the sake of time. And so this is more of an interactive protocol for payment. And at the end, what I've received is a bunch of orange tickets, which are these nanopayments. So I have these things which are only worth something if they're backed by a winner. So what I need to do is I need to go to the Orchid smart contract, and I need to show, hey, I've got these things from Nathan, these nanopayments. Are any of these worth anything? And so let's suppose that just for the sake of argument that out of all the orange tickets that I hand over to the smart contract, only the tickets ending in 7 are winners. So I'll walk through and I go, okay, this ends in a 1, this ends in a 2, this ends in a 4, 5, 6. Oh, here's a winner. So I show the smart contract, hey, I've got a winning ticket. And because these fiat payments were locked up in an escrow, that smart contract can now say, great, okay, we've confirmed you have a winner. This is provably secure, and we walk through how we actually secure this to make sure that neither Nathan or I can cheat this protocol. And they say, great, you have a 7. Here's a winner. And at the end of the protocol, I receive 1 payment. So you can see in both cases, I received one of these pink tickets worth $1. It's just that the protocols were quite different as we walk through them. So for instance, if I sent 100 payments with both systems, I may have sent $100 in exchange for 100 items in either case. But interestingly, you can extend this to very small scale purchases by adjusting the probability of these winning tickets downward to, say, 1 in a million chance of $1. And now you can pay for really, really tiny payments.
So let's now take a look at how on-chain crypto transactions compare to off-chain probabilistic nanopayment transactions. With on-chain transactions, every purchase gets written to the blockchain, and this requires paying a transaction fee. For small purchases, the transaction fee would completely wipe out any potential earnings. This is why you'll typically see minimum purchase amounts. With off-chain transactions, you're able to send many tickets with only the winner resulting in a transaction fee. This allows for the purchase of extremely small items that would be impossible to efficiently purchase with on-chain transactions. Let's examine this difference between on-chain and off-chain transactions through another exercise. For this exercise, rather than streaming a large 4K movie, we're going to attempt to stream a much smaller trailer that typically might cost about 10 cents there. So in order to convey this point, we're going to introduce a new type of ticket, a purple ticket that represents transaction fees. So we're going to start by showing off the on-chain situation here. So in this case here, Justin wants to watch a trailer, so he's going to have to hand over a purple ticket to pay the transaction fee. So he hands over a purple ticket, and he's able to watch a trailer. If he wants to watch another trailer afterwards, he's going to have to hand over another purple ticket and pay a second transaction fee. So now let's compare this, though, to the off-chain situation. In the off-chain situation with nanopayments, it's going to work a bit differently here. So Justin is going to hand over 2 pink and 2 purple tickets to cover a deposit as well as the transaction fees ultimately there. So in this situation here, we're going to tear up these purple tickets. It's not profit for Orchid. They're going to go to the miners instead there. So now if Justin wants to watch a trailer, he's going to hand over an orange nanopayment ticket. He's now able to watch the trailer. If he wants to watch another trailer, he hands over another orange ticket there. He isn't handing over purple tickets. He isn't paying additional transaction fees there. The only time those purple tickets he handed over at the start are actually utilized is if there's a winning ticket, which is going to happen very infrequently. So in the on-chain situation, despite the low cost of the trailer that we were showing before, the user ends up paying a very sizable amount in transaction fees compared to the off-chain situation. And this is all in addition to having to still pay the money up front to cover the actual cost of the trailer itself. So as you saw with the probabilistic nanopayments, you don't really need to worry about the transaction fees. And this allows us to make extremely small payments. With Orchid, we're even able to handle paying for something as small as a single network packet. But can you go even smaller? We encourage you all to think about why or why not this is possible. Come chat with us afterwards. Is it possible to pay efficiently for a single disk I/O or even a single CPU instruction? We've shown how nanopayments enable these small purchases, but what else do they enable? Small payments significantly affect the level of trust required of a provider, and they can reduce the trust burden down to minuscule levels, allowing for a truly decentralized, trustless system. They also make it possible to rapidly switch between providers.
So one of the things that nanopayments enables is actually interacting in a more trustless context. So finally, let's look at what happens when you introduce untrusted providers into our mix and who may not behave in a fair and honest way. So you might ask, if you pay up front, as we did in our system, why do you even get service? When you're trying to buy something from an anonymous stranger on the internet, if you hand them your money up front, you have no guarantee that you're actually going to get any sort of service in response. So I think we may, how are we doing on time? Good. Okay. Let's go ahead and go through this final exercise to talk about trustless interaction with nanopayments. Okay, so let's demonstrate something that's really only possible with nanopayments. For an untrusted party, you want to make sure that your balance of trade with them never goes out of whack. You don't want to hand $40 to a stranger on the internet and then just hope that they give you something in response. Instead, with nanopayments, you can hand them 10 cents or a hundredth of a cent as payment and see if you get anything back, and then you can interactively verify that you're actually receiving service, and at no point are you ever trusting them with more than a fraction of a penny. So let's go back to the trailer example, and let's imagine you're trying to pay for a trailer with a nanopayment protocol, but you're going to check that you actually, because you're interacting with potentially an untrusted party, you're going to check whether they actually send you the trailer, maybe they send you the wrong trailer, and if so, then you don't hand them any more money. Before, you couldn't hand them a very small payment like 10 cents because the transaction fees were dominating. When you have a transaction fee of 5 cents, sending 10 cents is very inefficient. So instead, you had to hand them maybe a large sum, like $1, or you had to set up a payment channel with them, which is also costly. And if they behave maliciously, you're out the $1 or you're out the time and expense of setting up your payment channel. With Orchid nanopayments, you actually only setting up a single payment channel with Orchid, and then anybody who accepts Orchid tokens is able to receive money from you now. So at those scales, at the 10-cent scale and so on, it may not seem like much, but what if we change the scale? And now with nanopayments, you're only losing a millionth of a penny or a thousandth of a penny. And with a traditional payment, you're trying to buy something worth $10, you might be out, an entire Chipotle burrito at that point. So let's go ahead and execute this protocol. In a traditional sense, Nathan's going to go ahead and hand me one pink ticket, but imagine that I'm an untrusted provider. I go, thanks, Nathan, that's $1. And then I walk away, and he's left holding the bag. So On the other hand, with the nanopayment system, he sets up his, as before in the last example, 2 pink and 2 purple tickets. Let me grab a couple purple tickets. So what he'll do is he'll hand those 2 pink tickets and 2 purple tickets over to the Orchid nanopayment contract. And those are going to go effectively into an escrow. And then I ask, hey, Nathan, you want to watch a trailer? Here, I'll give you some orange tickets so you can start making some payments. So he's going to go, sure, here's some nanopayments. And then I'll go, aha, I've got a nanopayment, and I'll run away if I'm malicious. But in this case, it's very unlikely that this nanopayment was even a winner. And so the amount of value that I've been able to take out of Nathan's pocket is really tiny in comparison. It's not $1, it's more like 1/100 of a cent. So I'm actually incentivized to stick around and see if he's going to download more. Because as long as it makes sense for me to stick around, then I have less of an incentive to walk away. So I might want to say, okay, here's a little bit of this trailer. So I'll go ahead and send him a few data packets. And then Nathan goes, great. Here's another 1/100 of a cent. And I go, oh, if we keep doing this, I might make $1. Okay. And so at no point is Nathan trusting me with really much of anything. And that enables applications that weren't possible with traditional payments, weren't possible with even payment channels, where the cost of interacting with an untrusted provider could have still been quite high, because once you create that payment channel, you're sort of locked into paying only that provider. So we asked the question earlier, if you pay up front, why do you get service? And we've answered that by saying, because you never make it clear for the person who might behave maliciously, you never make it clear for them to walk away, because you never trust them very much.
So most nanopayments don't result in a record on chain, but the rare winning ticket will result in a public payment record. This is why our Ethereum-based nanopayments are really only pseudonymous there. Users desiring stronger anonymity guarantees, they should try using a mixer or funding source like Zcash. And for multi-hop circuits, the Orchid client can even use a separate account per hop, which makes it more difficult to trace your circuit from public payment information. An adversary trying to trace the route may still learn some of the payment providers associated with a payer's public addresses, but not all of them.
So you might ask the question, how do we handle double spending? And we actually had kind of a cool way of preventing these attacks. Essentially, we require the payer to create a small burnable deposit. We sort of kind of glossed over that in the exercise, but a complete analysis of the various possible spending attacks and the required deposit size, that's all beyond the scope of this talk, but we do describe it in detail in our white paper, and we walk you through the full game tree, and we'll be at the booth as well to answer your questions about double spending.
So we've incorporated these probabilistic nanopayments as a core feature of Orchid to provide for the ability for our users to interact with providers at a scale in a safe, private, and affordable way. If you're interested in learning more about the nanopayments and potentially incorporating them into new and existing projects, we encourage you to check out our white paper and our introductory blog post. Also, be sure to follow us on social media and come check out our booth, ask questions, and get connected. We're here all weekend, and we'd love to discuss nanopayments in more detail with you. We also have a limited supply of free trials for Orchid so you can experience it all for yourself. Thank you.